Yeah, hi everyone. Good morning, good morning, good morning. So today will be the second lecture on linear algebra. And first of all, I need to confirm that, okay, whether my voice and everything is okay before I get started. Okay, so please confirm once on the chat box so that we can start the session for today, right? Yes. So already we have started. I have given you the basic of in the introduction part of linear algebra. What is the main objective and why we are discussing linear algebra? What is the need of linear algebra to discuss, right? And also I have given you my roadmap. What are the topic which are not given the syllabus. On in the syllabus only key topics are given, right? So today we will be understanding the elimination or matrices, right? Already we know what is the meaning of elimination, what is the method of elimination, and also we will see some of the again examples, right? So please confirm once if you are watching the session. So please confirm once. Okay. So yes. So let us get started. So this is the GCA lecture 2. Okay. GCA L2 on LA. Okay. On LA by me. Okay. Right. So as we have started with the system of linear equation, right? System of linear equation. Okay, to solve the system of linear equation, we are talking about linear algebra, right? And we have seen that if we take two equations and two unknowns, so today we are going to take m equations, right? And an unknown here. Okay, so I'm just gonna take two equations, m equation and unknown, right? So you see here, I'm going to write the coefficient in this format: a11, okay, x a12, okay, this is x1, okay, this is x2, and a13, x3, and so on, right? Like this we are going to write, okay? So here m equations are there. It means we have to take m number of rows, okay? We have to take m number of rows and n number of columns, right? So this 3 and 3 should match. It means it should be equal to n, right? So we can write it is a1n xn, right? And this is a1 a21, right? Because now we are writing the second equation, okay? So you can write first equation, you can swap also between equations, right? Whether you write equation first or equation second or equation second equation first, okay? Nothing is going to change in case of while finding the solution of matrices, okay? Solution of system of linear equation, okay? So that's what I will point it out, right? In a while. But when we will discuss about determinant, right? Okay. Yeah, good morning, Didi Priya. Okay, perfect. So A11 x1 plus A12 x2, A13 x3, A1n xn. So this is first row, you can say, or first column. Sorry, first equation, right? And this is gonna be again x1 plus A22 x2 plus, okay, these are the coefficients I'm talking about. A11, right? Shorthand representation of coefficient, you can say, or the element, right? A23 x3 and so on. This will be A2n xn, right? And just moving forward here, it will be a, you can say, how many rows are there? There are n number of m number of rows, right? So you can say that this will be am1, right? x1 and so on and so forth. This will be amn, okay? Here it will be what? Am, because we are taking what? Mm, right? And this will be how many columns are there, you can see here. So n number of columns are there, right? So you can say axn, right? So just I'm gonna write, this is the system of linear equation, okay? So what I want to say here is that, just I wanna write here, suppose we have got some equation, right? 2x plus y plus 5 equal to 5g equal to 0, and 3x plus 5y plus 3z equal to 0, and 7x plus 8, okay, 7x plus 8y, just a moment. Okay, yeah. So 7x plus, so already you have seen this, right? So let me go ahead only. So 2x plus y plus, okay, 5g equal to 0, some equation I'm taking, right? And 3x plus 7y plus 4g equal to 0, okay, and you can say 4x plus 6y plus 8g equal to 0. See, whether you say this is equation number 1, this is equation number 2, equation number 3, or you can also say that this is equation number 1, right, second, this is first, and this is third, okay? So you can write equation, you can consider any equation, right? Your solution of the system of linear equation will not change, okay? So okay, if you are changing the rows, see, if you are taking the equations differently, right? Suppose this is first equation, right? This is second equation, this is third equation, okay? Now you are thinking that this is the second equation, right? And this is first, this is third, right? So what you are doing here is you are changing the rows, interchanging the rows, right? Means this is row number 1, this is row number 2, this is row number 3, okay? So if you are writing equation one after another, right? First, second, third, or you can say second, third, first, or you can say third, second, first, right? So what you are doing here is, these are the elementary operations, right? You are just, swapping the rows, okay? So you can say that you are changing r1 to r2, right? Okay, or you can say that you are changing r3 to r1, okay? Suppose you are considering first equation as third equation, and okay, I believe this is fine. So this is very very important, okay? And the moment you see the linear equation, always keep in mind, the moment you see system of linear equation, you can write in shorthand form. Already I have told you, right, that form you can write ax equal to b format, okay? So these coefficient you see, I have written here these coefficients, right? This will be the coefficient here, and these coefficient we denote here, okay? Because after all, the matrix is basically the uh, a rectangular array of numbers, so we write this as aij, okay, m cross n, right? So what is aij? Aij is basically the shorthand representation of the element. Now, you can write here shorthand representation of an element, right? Okay, so A11 means what? Okay, the first row, first column and first row. Here M and N denotes the size of the matrix. Okay, this is the order of the matrix, you can say, order of the matrix. And M means M number of equations. Okay, what is the meaning of M? M means M number of equation. N means N number of columns, right? Or you can say N number of unknowns. Okay, so you have to understand that how we can write in terms of linear combination of column vectors, okay, and how we can write in terms of how can we plot, okay, system of linear equations on the graphs, right? So those things you should know, right? So last time also we have just discussed basic thing, okay, and you get an idea that how we have to study this subject as a vector language, in the language of vector, right? So please comment till this point everything is okay, like everybody might be familiar with this, right? So aij, here I is I denoting ith row, jth column, right? And m by n. Okay, so you guys can comment here how many people are here. Please comment so that I will come to know. Yes. Okay, so last time we have taken some example as well, and today also we'll take one example. Okay, two equations, two unknown only. Okay, so let me take two equations and two unknown here. You can say kind of question only. So x minus y equal to 1, right? And minus x plus y equal to 2. Okay. So this is the line number 1 or equation number 1, you can say. This is the equation number 2. Perfect. Okay. Now you see guys, we have got two equations and two unknown, right? Okay. So the moment you see this equation, you can take x, you can write this as in this format. 1 minus 1 and y means minus 1 and 1, right? And the left and right hand side is 1 and 2. Okay, so this is how we can write. This is the vector interpretation, you can say, the linear combination of linear combination of these lines. And you can see here, if you're going to solve these two equations, so what kind of solution we will get? Can you comment on a chat box what kind of solution we will get here? The value of x and y, guys, the value of x and y. See here, if you're going to apply the elimination, means both variables, you see x and minus x are getting cancelled, y and y minus, okay, both are getting cancelled. Okay, so we are not getting 0. If you're going to solve these two equations, so you are getting 0 equal to something, right? And 0 equal to something is not possible, right? So what is the meaning of this? This is inconsistent. Okay, this is inconsistent. Okay, so whenever in future, whenever you will start solving the system of linear equation, okay, systematically, which procedure I will tell you, right? So you have to always check first of all whether the equations are consistent or not, right? If the equations are not consistent, okay, if the equations are not consistent, means you will not get any solution. Okay, if the equations are not consistent, again let me repeat, two things are there. Okay, given the equation, okay, whether the equations will be consistent. Okay, if the equations will be consistent, so you will get unique solution, or you can get infinitely many solutions, right? Last time we have seen, okay, when number of equations were 1 and number of equation was 1 and the variable were many, right? तो आपको यहाँ पर समझना है कि the equations are inconsistent means you will not get any solution. Don't break your head, okay, determining the solution. And also you can see from the vector interpretation, okay, that this vector, okay, this column vector, the right hand side column vector, the b, cannot be generated with any linear combination of x and y. You see here, you take any value of x, any value of y, you can't get 1. Okay, if you take x equal to 1 and y equal to 1, so you are getting 0. You see, 1 minus 1, 0. But here you should get 1. Okay, yes, Vikas and Subham. Okay, so you see here, guys, by looking at the vector interpretation also we can say yes, and also we can plot it, right? So if you want to plot it in terms of row picture and column picture, also you can tell. So this is y-axis and this is x-axis, and just I'm gonna plot. So no solution means when two lines are parallel to each other, right? They're not intersecting anywhere, right? So you can plot easily, and you can say, you can comment on that, right? So this is y equal to x minus 1, so x minus 1, right? So here if y equal to 0, x equal to 1, so you can say this is a point, and x equal to 0, y equal to minus 1, so this is a point, right? So these two points you can join. Okay, this is one line, line number 1, or you can say row number 1, row 1. Okay, now you might be comfortable in the language, okay, the way I am speaking. Okay, now the second one is, you see, for this, if you take y equal to 0, so x is minus 2, So this is a point, right? And if you take x equal to 0, y equal to 2, right? So this is a point. So you can again join these 2 points. So you see here, these two rows are not intersecting, okay? These two lines are not intersecting. What is the meaning of that? Okay, row 2. So no solution you will get. Why no solution? Because the system is inconsistent. Okay, the system of linear equations are inconsistent, so don't break your head, okay? In the exam, they will ask questions and system of equations are inconsistent. Okay, immediately you can conclude that. Yes. And also when you will go for vector interpretation, right? When you will go for vector interpretation, so I'm just going to draw the vector interpretation as well so that you guys can understand. So just I'm gonna take these two equations and paste here, right? So x minus y equal to 1 minus x plus y equal to 2, right? So what you can do here is you can write in terms of vectors. So this is 1 minus 1 and this is by minus 1 1, right? And you have to get 1 and 2, but it is impossible. You see how these two column vectors are different from each other. Can somebody tell me how these two column vectors are different from each other? Yes, in the comment box please write. Okay, Subham and Vikas and Diti Priya, tell me how these two column vectors are different from each other. See, one is 1 minus 1 and second one is minus 1 1, right? So you are multiplying by scalar constant. Last time also I have told you that if I give you some bunch of vectors, okay, so what you can do, what kind of operation you can perform on the vector, you can add those vectors, you can multiply by some scalar constant, right, in order to increase the length, okay, or in order to change the direction, right? Suppose this vector is in this direction, and if you're going to multiply by minus 1, so this vector has the same magnitude, okay, but the direction will change, okay, but the direction of the vector will change. That is the basic thing one should know. So if you're going to plot this, right, so plot it, okay. So 1 minus 1 will be here, 1 is here, minus 1 is here. You can say this is one vector, you can say this is 1 minus 1. Now you have to plot minus 1 and 1. So you are multiplying minus 1 with this vector, right? But you can easily plot it. See, this is minus 1 and this is 1, right? So exactly opposite, right? Can we add these two vector, guys? Can we add these two vector by taking any linear combination, by taking any value of x and y? Yes, comment. Can we add these two vectors? And can we get 1 and 2? No, we can't get. Okay, so you see here from the vector interpretation also, okay, this is the vector interpretation. Okay, we can't add two vectors. Okay, here you take any value of x and y. Okay, you take any value of x and y. Why it is happening? Because the system is inconsistent, guys. Because the system is inconsistent. Okay, so the moment you see the system of equations, what you have to check? Given a system of linear equation, okay, two possibility will be there. One is consistent, right, and another is inconsistent, right? Consistent means like 0 should not be equal to some value, right? It should be 0 equal to 0, so you can say the system is consistent, right? So in this case, if right hand side is right hand side, okay, is some non-zero value and left hand side is completely 0, right, then that equation is inconsistent. So in case of inconsistent, you don't have to further do anything, guys. You don't have to do anything. You could directly claim that no solution will be there. Okay. But the moment you find that the system is consistent, so you can have two solutions. One will be unique solution, okay, unique solution, and one you can have the infinitely, okay, many solution, right? If the system is inconsistent, okay, so you can have only no solution, right? You don't have to further probe your solution, right? So this is very basic thing. And one more concept I have given you, okay. What was the concept? If the number of equations are, if the number of equations are less than the number of variable, okay, the number of equations are less than number of variable, this is very important point to remember, okay, for unique solution and for that, right? So number of equations, suppose number of equations are m and number of unknowns are n, okay. So I'm just going to give you some yes, Tanis, yeah, perfect, okay. See, based on number of equations, see, I'm not giving you any systematic procedure right now. Intuitive way of looking at the system of linear equation, okay, and directly guessing that yes, now I'm going to start my procedure from here and second my answer, right? So number of equation is m, suppose, and number of unknown is n, right? Suppose in this case, situation, what situation we can have here, right? See, there will be many solutions, okay, many conditions, not solutions, right? So we can have the number of equation equal to number of unknowns, right? In this case, when number of equation equal to number of unknown, right? So in this case, we can have three possibilities, okay, because this system is known as balanced system, okay. This is balanced, okay. This is balanced. Understand? This is balanced. Okay, this is balanced, okay. So because number of equation equal to number of unknowns, so what are the possibilities of the solutions? You can say we can have two possibilities will be there. One is consistent, one is inconsistent, okay. Inconsistent means no solution. In this case, you can have two solutions, two kind of solutions. One will be unique and one will be what? Infinitely many. Infinitely many. Okay. So I will give you the step-by-step procedure how to find unique and all in case of using matrices, right? And here you can have m, number of equations are less than number of unknown, right? Number of equations are less than number of unknown. Suppose there are two equations. What? Two equations, okay, and one unknown. Two equations, and sorry, three unknowns, not one unknowns, okay. Two equations and three unknowns. So in this case, always keep in mind, guys. In this case, always keep in mind, guys, you can't get, you again you have to check consistency and inconsistency, right? Okay. So in this case also you have to check whether the system of linear equation is consistent or inconsistent, okay. If it is inconsistent, no solution. If it is consistent, this is very important, guys, okay. In the gate examination, question has been asked and you can answer those kind of a question by blinking your eyes. Understand? You don't have to remember those concept of rank of a augmented matrix, rank of this, that, okay. I will tell, just wait and watch. So consistent, right? Consistent means here you can't get unique solution. Remember, here you can't get unique solution. Why? Because the number of equations, are less than the number of variable. Okay, understood? Okay, I believe this is fine. You are giving many inputs. But you are getting output as not expected output, right? So here you will get infinitely, okay, infinitely many solutions, right? Please keep uh, okay. Yes, some hazards happen, so that anyway, I'm just trying to recover that. Okay, so you see here, guys, I'm just writing again three situations. Okay, please, I hope you guys might have noted down, right? Because some error is coming anyway. So here m equal to n, here m is less than n, and here m is greater than n, right? You might have seen in control system also like over damped, under damped, okay, kind of a system. Yes. So this is balanced one. This is kind of, and this is unbalanced. You see. So in this case, see, M is here you can't get unique solution. Okay. Here you can't get unique solution. This is for sure, right? This is for sure you can't get unique solution here. No unique solution. Okay. Here only you can have no solution or infinitely many solutions. Okay. Infinitely many solutions. So please keep writing the notes as well, okay? Because sometimes some error is occurring today, so please take care of that, right? So in this case, you can have what? You can have the unique solution as well, okay? In this case, you can have unique solution as well, and you can have infinitely many solutions, okay? And if the system is consistent, then only you can have all these things, right? So, and in this case, three possibilities are there, right? So you see here for this case, this is special case, right? This is special case for which no unique solution will exist. Okay, so in the exam, if question is given, so first of all, what you have to check, how many questions are given and how many unknowns are given, right? That is what the story is. I hope this makes sense for everyone. Yes. Ax equal to b, you can say system of linear equation. System of linear equation. Okay. Here we can have b equal to 0 as well, and we can have b equal to non-zero. That also you have to take care. Okay. Ax equal to b. So this guy can be 0 and this guy cannot be 0, right? Okay. So these two things you have to also keep in mind. So we call this as homogeneous system of linear equation. Homogeneous system of linear equation. Okay. Linear equation you can say. And this is non-homogeneous system of linear equation, right? Okay. So when right hand side, okay, when right hand side is non-zero, okay, this is the meaning of non-zero. When v is non-zero, see, if I'm writing 0, what is the meaning of 0 here? 0 means, keep in mind, 0 means, uh, 0 means null matrix, okay, null matrix, okay. Hmm. Perfect. So, I think this is fine for everyone. Uh, wait for the moment, let me check. Yes, yes, Tanisk. You know, there is some issue occurring, but it's okay. We will manage for today only. Because not on the our session, just on the platform, right? Just where I'm writing right now. Okay. So I think this is fine for everybody. So till this point, everything is okay. Tanisk and Vikas and everyone. Till this point, everything is okay now. Yes. ठीक है. So now the main objective of today's session is understanding the process of elimination, right? But one more equation we will take, okay, in order to understand the infinitely many solution concept, right? So we have seen unique solution, okay, unique solution we have seen, okay, unique solution. Okay. In case of unique solution, what was there? In case of unique solution, right? So we have seen unique solution here, and in case of unique solution, when two parallel lines are there, two lines are intersecting each other and at one point, right? One point, so you will get unique solution. In case of no solution, two parallel lines are there, they are not intersecting anywhere, right? Okay. So this makes sense, I believe. And you can also talk in terms of vector interpretation, right? And now we will take one example. Now we will take one example where we will discuss the infinitely many solution concept, right? So, so you see here, I'm just going to take one example here, right? So you see, this is one very good example. So suppose we have got x minus y equal to 2 and minus x plus y equal to minus 2. So you see both equations are consistent. Okay. See, number of equations and number of variable is same here. Okay, number of equations and number of variables are same here, right? And consistency is there. First of all, you see how if you add these two, so you will get 0 equal to 0, right? If you get, okay, if you add these two, 0 equal to 0 means it is consistent. If it is consistent, then you will get what? You will get some solution, but you will not get unique solution in this case. Okay, why? Because 0 equal to 0 is coming. Okay, and if you take a closer look, the equation 1 and equation 2, right? So they are just different from minus 1, right? If you multiply minus 1, if you take minus 1 from second equation, so both equations are same, right? Okay, so you can also go for you can write in terms of matrix, okay, or so you can write ax equal to b. So this is 1 minus 1, right? This is minus 1 1, and this is x by, and this is 2 minus 2, right? Okay, or you can also write this as x times of the first column, the column number 1, column number 2, okay, x times first column. Okay, this is how we multiply, x times first column plus y times the second column minus 1 1, okay, and this is 2 minus 2, right? Now you see, you can plot it, right? You can plot and you can claim here. So if you are going to plot it, right, so what will happen? X minus y equal to 2 means y equal to 0, so x equal to 2 here, this is a point. X equal to 0, so y equal to minus 2, okay, this is a point, right? So you can say these are the 2 points which we are getting, okay, and both equations will be overlapping on each other, right? This is the overlapping case. Okay, if the equations are overlapping means what? You will get infinitely many solutions. Okay, these things you have studied in class 10th as well. So please confirm once if it is clear. Then we can go ahead and talk about elimination on matrices. Okay. Elimination on matrices, and you can also plot it. I mean, in terms of vectors. So let's draw the vector interpretation as well. Okay. this is just for your understanding, right? You don't have to do in the examination, okay? In the examination, what you have to do, I will tell. Perfect. So if I draw the vectors, so you see 1 and minus 1, so 1 and minus 1, so this vector is here 1 and minus 1, and this is minus 1 and 1, right? So you see uh, this is a vector, right? Okay, and this is what, this vector, this is minus 1 and 1, right? Just by minus, okay, and this is basically, you can write this as 1 and minus 1, right? So if you are going to multiply by 2, okay, in this vector, so you will be always on the line only, okay, you will always on the line. It means you can have many solutions on the line, you can have many points, many solutions, right? So that is what the main story is, right? So this is the picture here. So this will be equal to 2 and minus 2, okay? The resultant vector is on the same line, okay? So infinitely many solutions. I believe this is fine. Please confirm once, okay? Then we will go ahead and talk about the concept of elimination. Concept of elimination. Why elimination? Okay. See, elimination we have seen from very beginning, okay? Like elimination, how we how we process elimination, everybody know that, right? Suppose we have got x plus y equal to 3 and 2x minus 3 by equal to 4, right? These two equations are given, so we can apply elimination method and we can find the, we can find what, we can find the value of x and y, okay? So what is the meaning of elimination? Elimination means deleting one of the element, one of the unknown, okay, and finding other unknown, right? Deleting one at a time, okay. So what is the meaning of deleting one row? Okay, how can you delete one? Suppose you want to delete this x from here. So what you will do? You will take 2 and you will multiply here in the equation 1. So you will write 2x plus 2y equal to 6. See, if you are if you are taking this coefficient, if you want to make these 2x, this x, if you want to eliminate from the equation, right? So that you can get by. So what you will do? You will make these two terms same. What is the meaning of that? You are making, suppose in terms of matrix, right? You are making, suppose this is 1 and this is 2. So you want to make this 2 0, right? You want to make this 2 0. So you will apply some operation over there, right? Okay, so in case of system of linear equations, so it is visible that yeah, you are deleting that variable, okay, and determining another variable. But in case of matrices, what will happen, so you have to apply row operation. That row operation will help you to eliminate, okay, eliminate some of the element, some of the rows from the, okay, some of the rows, some of the column from the matrix, right? I hope this makes sense. So you see here we are multiplying 2 in the equation 1, so this equation became this, right? So if you are multiplying 2 on this term x, okay, so you have to multiply in entire equation. It means you have to multiply here in entire row, okay, then subtract it means then you have to subtract from row number 2, means you have to subtract from equation number 2 and equation number 1. See, so 2x minus 3y equal to 4. Now you subtract minus plus minus, okay. Again there is a error, right? Okay, so the question of elimination we were discussing, right? So we can take again x plus y equal to 3 and 2x minus 3y equal to 4, right? So as I discussed, this is a concept of elimination, right? Concept of elimination. Yes, it's okay. So x plus y. So suppose you want to make this guy 0. So 2x plus 2y equal to 6. and this will be 2x minus 3 by equal to 4, and you are subtracting, right? So this becomes 0, and this is basically 5 by equal to, this is going to be 2 here, right? And then by equal to 2 by 5, right? So you got by equal to 2 by 5. Okay, so now you can find x as well, right? So what is the meaning of elimination on the matrices, right? That you have to understand, right? So I think this is fine. So if I'm writing this is first equation, this is second equation, you can also write this is first equation, second equation, this is first equation. What is the meaning of this? The meaning of this is nothing but, you are switching R1 and R2. And if you are switching R1 and R2, remember this, if you are swapping R1 and R2, these points you can note down also, okay? And I am explaining from the very basic, right? So, because many students have a lot of confusion, why we apply elimination, why we apply R1 minus R2, R2 minus R1, right? Okay, they only understand that key we have to reduce it to echelon form, that's what we do, right? But how this, whether this will impact your solution or not, whether these elementary operation will affect your solution or not, no, right? So R1 and R2 if you are swapping, right, so it will not affect our solution. Okay, the value of x and y will be same, right? Okay, it will not affect our solution. Okay, I believe this is fine. So some glitches are there, it's okay. Huh? So swapping, this is the process. Okay, this is row, you can say row exchange. See, if you are exchanging equations, okay, if you are exchanging equations, right, it means you are swapping. Okay, row swapping you can say, or row exchanging, so your solution will not get affected. Okay, but remember here I am just giving you the kind of note, determinant will get affected, determinant value, right? That of the matrix will get affected. Okay, when we will discuss about det, okay, det is just a value, not a matrix. Okay, det of a matrix we always evaluate. Okay, so det will get affected. Okay, if you are swapping, okay, that will get affect. Okay, like the value of the det, suppose what I am trying to say here is that suppose we have got det of the matrix A is 2, and if there is situation like in the exam they have given R1 and R2 swapping, right? If you are switching R1 and R2, so what is the matrix det B of the matrix? So det B will be equal to -2. Okay, det B will be equal to -2. Understand? Suppose matrix A is given. Okay, the matrix A is given and the matrix B is given. Okay, but there is a R1 and R2, right, situation. Okay, from the matrix A, right? You can say this is equal to matrix A, where this operation has been done, okay, on matrix A, right? So this will affect, so this minus sign will come in front of the determinant. But in case of solution, nothing is going to different, nothing is going to change, right? This you have to keep in mind always. Many students have lot of confusion in this, right? So if you are taking first equation as second equation or second equation as first equation, means what? You are interchanging rows, guys, nothing else in terms of matrix, right? Inside the matrix, what you will do, you will interchange rows and column. Yeah, depending upon the need, you have to do it, right? Okay, and if you want to make, suppose if you want to make this variable x, you want to completely eliminate from the equation, right? So what you will do, you will take this coefficient, this is the scalar multiplication in the first row. Okay, so 2 multiply by 2, then subtract it. Okay, so now I will take one original matrix and perform elimination, And elimination is not new. Okay, so elimination means what? Elementary operations you have to perform on the matrix. Okay, elementary operations. Okay, elementary operations, what can be elementary operations? You can take one row. Okay, you can take one row. Okay, you can completely eliminate that row. Okay, row elimination you can say, right? Understood? Suppose you want to eliminate row 2. Okay, so what you will do, or you are applying some operation on row 2. So R2, you have to write first R2, then R2 minus some multiplication lambda times suppose R1. With the help of R1 you are eliminating. So you have to write like this. R2 tend to R2 minus lambda time R1, right? I hope this makes sense for everybody. Okay, so elimination is not new. In terms of equation you were doing, now you have to perform elimination on matrices, right? So there are three basic elementary operations. Okay, whether you can eliminate, you can apply operation on row, or you can apply operation on column. You can multiply by any, suppose any row is there R2, so you can multiply lambda times R2, right? You can do like this. You can also you know uh, swap R1 and R2 like this. So these are the elementary operations. Okay, and they will not affect your solution, let me tell you. So whenever system of linear equation will be given, happily do anything. You can keep going until you get the uh, until you reach to your solution. You can apply elimination, you can apply elementary operation without having second thought in your mind ki sir has told me like this. If you don't know the rank of the matrix, then you can't get the solution and lose 5 marks, right? What is your fundamental in your mind? आपका माइंड में क्या फंडामेंटल है? आपको क्या पता है? आपको केवल एक चीज पता है. क्या पता है? कि रैंक ऑफ द मैट्रिक्स, अगर आगमेंटेड मैट्रिक्स का रैंक और ये वो जो भी होता है कॉन्सेप्ट, राइट? ठीक है, अगर वो कॉन्सेप्ट भूल गया तो एग्जाम में आप नहीं कर पाते हो क्वेश्चन, right? I hope this makes sense. Okay, but in my class I'm generalizing everything, right? So you will never ever get confused. Okay, you can see here the elimination which you have been getting carried, okay, from your class 10th high school, right? System of linear equation. The same thing we are doing here in terms of elementary operations, and nothing new. And I'm claiming that the solution of system of linear equation is not going to change. I hope this makes sense. Yes, please now put your comment on chat box. Okay, if you have understood and it is not new. Okay, have you accepted that it is not new? Okay, it is not new, completely not new, right? It is purana, it is old, right? Now let's take one equation. I'm just going to perform elimination, right? So I will be taking three system of linear equation and I will systematically solve it. Okay, systematically apply elimination and see how I'm applying elimination. The same method you have to do always in order to get any question in second. Okay, in any question to solve in second, right? That's what my claim is. And you can go for PYQ after this session. Okay, and yes. Okay, so what are the elimination here? So elimination means Gauss elimination method we call it, right? So Gauss elimination, okay, elimination method. Gauss elimination method में the very first will be interchange row and ith row and jth row. You can interchange two row, I mean to say, right? Interchange ith row and jth row. Okay, second. What is the meaning of this? Ri can be interchanged Rj. So this is one of the very good paradox, guys. if you are interchanging or swapping rows, the determinant value of the determinant will change. You can note down the solution of system of linear equation will not change. Okay. Next, multiplication of ith row by a non-zero number. Okay, so you can do multiplication of ith row by a non-zero number. Okay, why you are multiplying by non-zero? So that it will not become zero. Okay, and you can add, you can eliminate some other row, right? So you can say lambda is a non-zero number, right? So you can say ri, you are multiplying lambda in the ri ith row. Okay, so ri will be equal to lambda times ri, simple. Okay, why we are multiplying? While applying elimination, we want to delete x or delete y. So we have to take the coefficient of second equation, multiply in the first, so that both should match. Okay, both terms should match. Okay, so that we can cancel them. Understood? How beautiful the concept is, you see. Next, third. These are not new. Again, let me tell you, these are not new. Okay, and addition of lambda times means you can add addition of lambda times the jth row, lambda times the jth row. Okay, any row you pick up, jth row, any row, multiply by lambda and add to ith row, to the ith row. Okay, this is the language of matrix. So what is the meaning of this? If you are adding on ith row to ri, you are performing operation on ri. So you have to first write ri and ri plus lambda times of rj. These are the three elementary operations which we will be performing. Now the question is from where to start and from where to end. That is also very important in matrices, right? From where you can start applying elimination. In system of linear equation you can do directly, right? If two equations are there, so either you can eliminate, you can delete one variable and find another. In case of 2 by 2 I am talking about, two equations, two unknown. But in case of three equations, three unknown, what you will do? Okay, that makes sense. Understand? So you can't do directly, right? I mean, you can't delete one equations and one of the term like x and okay, and then you can find y and z, right? Okay, so you have to go and ask matrix, please help me, give me some systematic procedure. Okay, I hope this makes sense for everybody. Chalo, next. So the thing is, I'm just going to take two equations. I mean some of the equations. Okay, and we will be having the proper elimination, right? Proper elimination we can apply. Understood? So I'm just gonna take some matrices here, system of linear equation, and then we will solve it, right? So yeah. Just wait for the moment. Let me take questions from. Okay, very good question I will take so that we can learn complete process of elimination, right? Yes. Perfect. Okay. So in gate examination also this question was there. I will give that question as well before I take the elimination. Gate 2023 CS. Okay, this year it was asked, right? What was the question? The matrix A was given like this. Okay, like 1 2 3 4, right? And 4 1 2 3. Okay, 3 4 1 2, right? And 2 3 4 1, right? So this was a question A, and the matrix B was given. You see, now you have to observe matrix. Okay, so this was 3 4 1 2 4 1 2 3, okay, and 1 2 3 4, and this was 2 3, okay, 4 1. So these are the two matrices they have been given, right? So now they are asking what is the relation between det A and det B. What is det and det B? Okay, so they have given some options as well. So options are like det A equal to det B. Anybody can answer this question, please answer. Okay, it was asked in computer science 2023. Okay, det A equal to det B, det B equal to minus of det A, and C equal to det A equal to 0, right? And D equal to det AB. The product of det AB equal to det A plus det B. So which one is correct? Which option is going to be correct? Yes. Which option is correct, guys? Tell me. Yes. Anybody can try this question. I think now you understood the concept, right? Det, if you don't know how to calculate det, don't worry at all, right? But by looking at these two matrices, it's a gate problem, right? So it should not take that much time. Okay. So you see here, how many rows are there? How many rows are there and how many columns are there? You see here, this is 4 by 4 matrix, right? 4 rows and 4 columns. This is 4 by 4 matrix. Okay, clear. Next, how many rows are there? You see the row number 1. This is row number 1, row number 2, row number 3, row number 4. 1 2 3 4, 4 1 2 3, 3 4 1 2, and everything, right? You see here as well, there are 4 rows. But what is happening here is that you see your R2 and R4, R2 and R4 are same, okay, but you see here this is R1 and this is R3. In this case, this is R3 and this is R1. Okay, so what is happening here is that there is a row exchange. R1 is interchanging with R3. If this condition comes, so what will happen? The determinant will get affected or not? Please write on the chat. See, until you respond, okay, I cannot understand, right, your expression, right? So please respond as well. If you have to do closer examination, you have to put your observation in the exam, right? Here you don't have to waste your time, right, thinking about. So here you're swapping R1 and R3, right? So the answer for this question will be option B, okay, because R1 and R3, if you are interchanging, you see that in the matrix A, this was row number 3. R2 and R4 are same, but in this case, now it has become R3, okay, it has become R1. So what you have done? You have taken the equation number 1 as equation number 3, and you have taken equation number 3 as equation number 1, okay, nothing else. See, suppose there is a row 1, row 2, row 3 and row 4, right? So as I said that this is first equation, second equation, third equation, fourth equation, right? Because from the system of linear equation only you will get the matrix, right? So if you are going to write equation number 1 in place of equation number 1, the equation number 3 here, right? So you write 3 here and you write 1. So what you are doing in terms of matrix? You are swapping these two rows. R1 is being swapped with R3. If you are doing this, so your determinant value will get affected. If one time swap is there, two rows are interchanging, right? So -1 will come into picture. Understood? Okay. If other rows are also having exchange, so -1 into -1, right? Number of times row exchange will bring -1 in front of the determinant of the matrix. ठीक है? I hope this makes sense. And इससे ज़्यादा तो नहीं समझा जा सकता. This is very intuitive. Okay, this is very intuitive. Remember. I'm just trying to explain you intuitive understanding. Okay, don't waste your time. And my session in next 15 hours, right? You will be the crazy about linear algebra. Any question you can solve it. Okay, at least in terms of in the level of gate and beyond gate as well, right? And these session will definitely help you in your AI machine learning, in future when you will go for ISC and all, right, to pursue your MT. And it will also help you to get good rank in gate exam. ठीक है, चलो. I hope this makes sense for everyone. So we will take the question. Okay. So now we will take systematic procedure and we will wind up the session then. Okay. See, one more question was there in electrical engineering, right? One question was there in electrical engineering we can take because talking question is very important. Gate electrical 2023. What was the question? The question was in the figure was given like this. You see, two vectors are given. One vector is this. This is 0, 0. Okay, this is a vector here, u vector, and this is v vector, right? And this vector has a coordinate 4 and 3. Okay, coordinate means this is first component, this is second component. In terms of column vector, how you are going to write? This is 4 and 3, right? And this is v vector which has coordinate 5 and 0. So you can say in terms of column vector you can write 5 and 0, right? Simple. Now the question is, in the figure the vector u and v, okay, these two vectors are related as you can say a u equal to v. Okay, this is the relation. What is this relation? Okay, where a is a matrix, and u is a vector, right? And v is also a vector. So yesterday only I told you in the introductory class, when matrix into vector is there, right? When you are multiplying matrix into vector, you will get the vector itself. Yes, you will get the vector itself, guys. Okay. So in the exam, what they have asked, you have to find the matrix. What matrix is correct? So I'm just gonna write 4 by 5 and 3 by 5, right? So minus 3 by 5 and 4 by 5. Option B is 4 by 5 minus 3 by 5. These are the element of the matrix. That's it. 3 by 5 and 4 by 5. Option C is given 4 by 5. Okay, from the next time I will take question directly and discuss, but today just I'm writing, right? So these are the C, okay, and option D I'm writing here, right? So 4 by 5 and 3 by 5 minus, okay, this is 3 by 5 and 4 by 5. So if you have attended my session, right, then you should not face any challenge here, right? The question is, in the figure the vector u and v are related as a u equal to v by a transformation matrix A. So this matrix A is called the transformation matrix because it is transforming one vector into another vector, right? So what is that matrix is? Very simple question. Very simple question. Okay, so what you will do here, just take any matrix from the options, okay, and multiply it. So we can take option A. Okay, just take option A, right? So a u equal to v, you have to get a u equal to v, remember this, and this concept will also help you to understand eigenvalues and eigenvector, right? In that you will see ax equal to lambda x, here a u equal to v. Okay, so this is not the, this vector is not the eigenvector, okay, remember, because u and v are different, okay, from each other, right? So a u equal to v here, let me see how they are differing. They are different, yes. So the matrix A I'm taking from the options. So this question can be done from the option to question, right? So 4 by 5, 3 by 5, 4 by 5, 3 by 5, and then you can take minus 3 by 5 and 4 by 5. Okay. I think electrical people might have solved this question, right? So this is given as 4, 3 and this is 5, 0. So if you have attended my session, so there will not be any confusion, right? So matrix into multi vectors, Okay, so how can you multiply these two, so what you can, some errors. Okay, let me write here the matrix again. 4 by 5, 3 by 5 minus 3 by 5 and 4 by 5. I think this is the matrix. Okay, yes, and the vector is 4 and 3. Okay, and this is going to be 5 and 0, right? So yes, just wait for the moment, guys. I'm just getting back. Okay, yes. So I'm back again. So let me take that the same one. Like we were multiplying two matrices, I mean one matrix. Okay, the option A we have taken 4 by 5 and 3 by 5 minus 3 by 5 and 4 by 5. Okay, and here we have taken the vector 4 and 3. Right. So I think there is a glitch in the system, right? So we will continue our session, right? From the next time only, because I think there is a error, right, in my so I'm just going to yes, guys. So what is happening here is that there is some error, right, in the writing pad. So I'm gonna correct. So I hope this session might have been interesting. Okay. Whatever concept I have delivered to you, right? One more thing I would like to ask here is, you can carry out this question like you have to multiply a times u and you have to get b, right? So if you don't get, you can write in, to me on chat box, right? So yes. So because I'm getting error, so why to all the time discontinue? Okay, why to become a discontinuous function, right? Yes. So if you have any doubt, let me know so that we can answer now and then we can wind up the session. How was the session? You can also let me know on the chat box. Yeah, because I think I started from very basic, damn basics, right? And I was trying to, why I'm trying to, do like this so that the confusion which exists in your mind, arey yaar, this is new thing, right? Nothing is new, okay? Because in the life, if you have got a problem, you have to find some solution to solve, right? That is what my practice is, right? From very beginning. When I graduated and when I became aware, right? I was also not aware about these things, right? So after pandemic only I became aware about these things. So I thought of sharing with you. So you guys can share your feedback as well on the comments, right? How we are moving ahead. Yes. So Saurabh, everything is okay now. Tanishq and Diti, Priya, Vikas. Okay, and yeah, we will continue from the next session, right? So we will discuss, we will try to apply those Gauss elimination, yeah, that Gauss elimination method on the matrix, and systematically we have to solve, right? Uh, till now you have just understood the motivation behind elimination, right? Okay. Chalo, so if you don't have any doubt, we are just winding up the session. Thank you so much for today. And I hope you might have prepared the notes as well, right? Because of that glitch, I can't share the PDF for today, right? Okay, thank you so much.